Good afternoon. I'm Arun Serafin, Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. Thank you to all our attendees for your support of NDIA and ETI, and thank you for joining us for today's webinar, Generative AI 101 with Dominic Ross. This webinar is part of our Tech 101 series, where we present complex technological concepts as introductory webinars with a focus on their national security implications. Today's webinar is on the cutting-edge intersection of generative AI and defense. As global security environments evolve, so does the technology that protects and enhances our strategic capabilities. Today, we are discussing how generative AI, artificial intelligence, is transforming defense sectors around the world. Our session will explore the foundational aspects of generative AI technologies, specifically focusing on their applications in defense, from autonomous drones and predictive threat analysis to cyber defense and simulation training. These tools are not only for augmenting existing capabilities, but also for forging new methods for strategic defense planning and operations. The irony of all this being generative AI can also help webinar hosts, such as myself, write their introductions, which it just did, and you can judge the results for yourself. Some administrative remarks before we get started. 1, all attendee lines are muted. 2, if you have questions during the webinar, you can submit your question in the question box on the webinar panel on the right side of your screen. We will do our best to get through all the questions during the Q&A session at the end of the presentation. 3rd, we're recording today's webinar for members unable to attend and for any member who wishes to review the material at a later date. Within the next few days, we'll also post the slides and the recording to our website and YouTube channel. Now I want to introduce our presenter for the day. Dominic Ross is the broadcast media team lead and an AI engineer at the Carnegie Mellon University Software Engineering Institute. His work includes projects on multimedia research and transformative gamification. Prior to joining SEI, Dominic worked in multiple roles in multimedia production and has experience as a digital media effects artist, a broadcast television technical director, and an AI engineer. Dominic, I want to thank you for sharing your expertise with us today. With this, I'm going to turn over the webinar to you. Thanks, Dominic.
Thanks, Aaron. Okay, so I'm just going to share my screen, and if somebody can just confirm when they can see it.
We can see it.
Great, wonderful. So, as already said, I'm Dominic Ross. I'm here to speak with you today about generative AI, also called Gen AI. This discussion today is really much going to be at the high level, introductory type of presentation. Unfortunately, you're not going to see a lot of real life examples. As part of an FFRDC, I'm limited to what I can discuss from the tools and software perspective publicly, but as you can see from the stock imagery that's going to be in the presentation. But I can promise you that if you want to see real life examples and tutorials, they're just a quick web search away. So if you're looking for a deeper dive into generative AI, please let us know, and we can possibly set up a more in-depth talk later on in one of these type of series. So just to get started, this is essentially something that we have to show. Generative AI sometimes makes things up. My organization's worried I may do the same. So they provide this legal document outlining their stance on this presentation. It's basically saying that there's no warranty with the information. I'm not necessarily representing the university, but it's all publicly available knowledge. So a little bit more about me. As we already discussed, I started my career in film and television production. I made the transition to an AI workforce development engineer recently. I'm not a data scientist. I don't play one on TV. I don't pretend to be one. You're going to get a much more practical type of presentation from me than you would from a data scientist. It's much more from the point of view of somebody who transitioned into the role of generative AI research and development. I really got my start in generative AI by researching deepfakes. That's when I got my first introduction into actually creating synthetic data. I've deployed my own local large language models. I've trained synthetic voices. I've built my own fine-tuned image-based Gen AI models. And heck, I've even used Gen AI to create cartoons in 3D environments. So got a lot of practical experience. Today, we're going to be really focusing on an introduction to Gen AI. That's going to be the primary part of the talk, where I really introduce you to the core concepts, the technology of the models themselves. We might get into some of the advanced concepts of Gen AI, though. When we talk about like neural networks, specifically relating to deep learning or general adversarial networks. We'll get into the practical application and impact that generative AI has, challenges and ethical considerations, especially when it comes to a DoD focus, and finally, conclusions and some future directions of Gen AI for the DoD. So let's go ahead and just kind of launch right in. What is generative AI? It refers to a type of artificial intelligence technology that can generate new content, such as text, images, musics, other forms of media based on existing data it's been trained on. This technology utilizes machine learning models, particularly those based on neural networks, to understand patterns, styles, or structures from large data sets. And then it creates output that is similar but not original. Generative AI is very much a branch of machine learning. Within itself, it's a subset of artificial intelligence. Machine learning provides the foundation for generative AI by offering the techniques and algorithms that enable computers to learn from data and make decisions or generate new content without explicitly being programmed on those specific tasks. So let's simplify that a little bit. Think of artificial intelligence, or AI, as a vast library where machine learning, or ML, is a method that teaches computers to learn autonomously from the books of data that encompass this library. As the technique allows systems to refine their abilities over time, AI utilizes it to simulate intelligent behavior across a broad spectrum of tasks, effectively learning and adapting without direct guidance. Generative AI holds a unique position within this AI library. It not only uses existing information to perform tasks, but actively contributes new and unique content that can enhance and expand the AI's capabilities. So, let's talk about how generative AI learns and the type of methods it uses for learning. It's really three types: supervised, unsupervised, and semi-supervised learning. Each method offers a unique approach to understanding and extracting value from data, and the choice of which one to use depends on the nature of the problem that you're trying to solve and the data that you have available, right? So we talked, first one is supervised. So supervised learning involves models that are trained on labeled data sets. So if we remember that AI library example, it's akin to studying with a book that has all the key points already highlighted in it. These models rely on input-output pairs to learn a function that maps inputs to that desired output, making them really, really well suited for tasks like classification and regression, where the correct answer or labels are known for training data. Now, unsupervised learning algorithms are designed to identify patterns and structures in data without any pre-existing labels. So it's akin to going through a vast, subset of books, uncategorized in the library. We have to discern and organize the books based off their content alone. These algorithms are really good at tasks like clustering, where they categorize data into groups with similar features, and density estimations, where they infer the probability of distribution of the data set. Such models are invaluable, like uncovering hidden relationships within the data without any additional guidance. Now, the final one that we're going to talk about is semi-supervised learning. And that falls between supervised and unsupervised learning. It's used when you have a large amount of input data, but only some of that data is labeled. This approach is similar to having partial summaries of books. So if you remember back maybe when you were in high school, you had to read a book like To Kill a Mockingbird, and you may have the cliff notes, or you had a friend that had the cliff notes that basically summarized the content. It didn't give you everything you needed to pass the test, but it gave you a kind of a basic understanding of the concept itself. So it could guide you on what to focus on, but also require you to explore the content independently to gain a better understanding. So what does all that mean? Well, let's just take a look at a quick diagram, right? So supervised learning, as I already said, we have our labeled data. So in this example, we can see there are a number of hearts, bolts, crosses, and they have labels. So our model knows what a heart looks like, but it also knows what its heart's called, so with a bolt and a cross. And so it can take a test data set and it can predict whether or not that falls within a heart, a bolt, or a cross, despite it being slightly different. Now, again, the unsupervised model, we have this data set, and our input data is a bunch of images, but that are similar. So we have a bunch of crosses, a bunch of bolts, a bunch of hearts, and the model trains to categorize that data and look, okay, what is similar? And by that, it can create an output that basically says, okay, the hearts, the crosses, and the bolts all belong together. Basically creates a subset of that. When we look at this semi-supervised learning model, there is the input data and partial label. So we have a label for a cross and a bolt in this example, but we don't have the heart. But the model can train, and I can supply it data that it's unfamiliar with. And through a process of elimination, it can ascertain that it could be a heart, right? So it has some of the input data, but not all of it, but it can still be useful. Okay, so let's grow our understanding a little bit more. Deep learning is a type of machine learning where computers use structures called neural networks to learn from large amounts of input data. They take advantage of that semi-supervised learning method that we talked about, learning from labeled and unlabeled data. These networks, which are layers of processing units, mimic neurons like that of a human brain, and they allow the computer to recognize patterns and make decisions. As the data passes through each layer, the network learns to understand increasingly complex features, enabling it to perform tasks like recognizing faces, translating languages, recommending movies. Um, in my experience, when I was doing deepfake research, I used to watch these neural networks all the time in the command line. And there's a scene in The Matrix that he's an operator is watching The Matrix and he's watching the code move, and he's seeing it kind of train and learn and iterate and model its behavior. And he says, I don't even see the code anymore. I just see what it's going to produce. I feel like if you worked long enough with deep learning, you can kind of get that same experience where you'll be looking at the model as it's training, and okay, it's at the point now where it can start recognizing faces. It's at the point now where it can start recommending movies accurately just by kind of looking at the training that's going on. Now, if we build on our deep learning understanding, general adversarial networks, or GANs, they operate on a system of two competing neural network models. And so we have a generator and a discriminator. The generator's job is to create data that is indistinguishable from real data, while the discriminator's job is to distinguish between actual data and data produced by the generator. So through this competition, the generator learns to produce more and more convincing data, and the discriminator gets better at telling real from fake. This adversarial approach continues until the generator produces data that is so similar to the real data that the discriminator can no longer tell a difference reliably. So it's a real kind of cat and mouse game. Creates the data, evaluates the data, iterates, improves, and keeps going into the point where the network can no longer really tell that the data is synthetic. A great example of this is people that don't exist. You see it a lot when it comes to graphic design professions, or heck, even in misinformation campaigns where these individuals that don't exist are being compiled of large data sets of humans that are compiled together to create a synthetic human. So you can kind of see on the right there, I created a prompt of myself. I think I did a reasonable facsimile of trying to recreate me without much data or my likeness. So we talking about data a lot, and how does it really learn on this data? So the saying a good artist borrows and a great artist steals like really rings true for me when I think about this, especially when I was in art school. So I used to be shocked to see how often artists began their creative journey by like tracing and imitating other people's works of arts. This method of mastering the fundamentals through emulation is not unlike how Gen AI learns. It borrows by analyzing existing data, be it art, music, or text, and then steals the essence of that data to create something entirely new. So just as an art student evolves their style over time, becoming great by building on what they've borrowed, generative AI uses its algorithms to produce content that transcends the sum of its inputs. And I kind of created this graphic here just to give an example of where this happens in real life. So there are these painting classes that people get together and they go to, and they have an instructor, and the instructor has a painting, and you go and you drink wine, and they teach you basically how to recreate this painting. And the painting that you create isn't exactly the same as the one that the instructor shows you, but it's a reasonable facsimile. It's kind of the same way that Gen AI learns. You have a lot of people in this class, people iterate, they talk to one another, they produce this work of art. Some may be better than the other, but ultimately it's something unique entirely. Now, all this intelligence, generative AI, though, operates without consciousness. It doesn't have personal experience. It doesn't have feelings. At the end of the day, a computer can only do what you tell it to do. Generative AI performs an advanced form of pattern recognition. So it, again, as we talked about in the painting example, it deeply analyzes the structures and relationships in the data that it's exposed to during training. But it still needs prompts. Prompts are the inputs or the instructions provided to the model to guide the generation process. They're critical in directing how the AI operates, influencing the output by specifying what model should produce and how it's, what it should consider when it's actually creating this generative content. And we'll get a little bit more into prompting later in this presentation. Okay, so computer can only do what you tell it to do, but it has to be able to, create something. So essentially, it's either a discriminative model or a generative model really that's relying on for this. So a discriminative model predicts a labeled base on the input features, while a generative model simulates how the data is generated, capturing using underlying distribution. So consider machine learning task involving different breeds of horses. A discriminative model would act like a judge at a horse show, right? It'd be really good at identifying, the breeds based off of specific traits and classifying them to distinguish, okay, this is a Clydesdale versus this is an Arabian horse, just by their feature sets alone. While the generative model is more like the biologist. And not only is it able to classify the breeds, but it also has the understanding of their genetic makeup. And it can understand it well enough that it can simulate and generate realistic examples of each breed. Thus, while the discriminative models excel at like classification, generative models offer like those deeper insights and the ability to create something new or a plausible example of a horse, for example. So, there has to be prediction that occurs. So a predictive AI model focuses on the forecast outcomes based on the input data, aiming to predict future events or behaviors. The effectiveness of this prediction model is influenced by the distribution and separability of the classes in the data set itself, as well as the relationship and interactions among the features, which determine how well the model can learn and generalize new data. While generative AI models, again, are designed to create new data, the instances that resemble from the training data they have, and they're really good at creating things like text, image, other forms of content, natural language processing. While the predictive model is really focused on forecasting the outcomes, the generative model creates new data samples. Transformer models leverage self-attention mechanism to handle a wide range of tasks, from predicting analytics to content generation by complex patterns and relationships in those data sets. So when we talk about transformer models, it's really a neural network that's particularly powerful at processing sequences, such as natural language processing or NLP. Unlike earlier models that process data sequentially, one word at a time or one image at a time, transformers allow for parallel processing of all the words in a sentence. This is achieved through a mechanism called attention, which lets the model focus on by assigning weights to different parts of the input data, allowing the model to focus on relevant parts of the input sequence for each word it processes. The architecture supports both input, like reading a sentence, and output, like generating text, making it ideal for such tasks, again, as language translation, translating code, text summarization, generating human-like responses in chatbots. In fact, GPT stands for Generative Pre-trained Transformer. Okay, talked a lot about different models and data, but there's also something you really got to keep in mind when you're training models, and that is you really need to think of yourself like a data scientist who's a chef. And as the data scientist prepares the data set, their role really resembles that of that chef who's assembling ingredients before the actual cooking begins. So from there, the creation of AI content diverges into distinct types. Textual content emerges through the intricacies of natural language processing like GPT. Images take shape pixel by pixel thanks to precision convolutional neural networks. They further refine by creating this adversarial dance of the GANs that we talked about. That's a cat and mouse game. And data sets are synthetically created and curated, and they become the backbone for other models, enriching AI's learning experience. They could be audio sequences by recurrent neural networks, forming this complex layers of sound even. So how do we tell it what to do, right? We have the data, we have the algorithms, we have the models. It's really about prompting, as we've already, priorly discussed. And prompt engineering is that practice of designing and refining the input queries given to AI models to elicit the most effective or desired responses. It involves optimizing prompt wording, structure, assigning roles and responsibilities specifically to guide the model's response, ensuring a higher accuracy, creativity, or relevance. So a quick example. If I was going to create a prompt and I wanted summarization of a news article, I may tell a large language model to think of itself as a newspaper editor and to look at the data set that I'm providing or the text that I'm providing and summarize it like you would for a high school student's understanding and make it no longer than 500 words. So that's kind of a brief example of what prompt engineering is. It's using things like descriptive prompts. These provide details for detailed descriptions or clear instructions on what the output should contain. For text, this could be a specific scenario or question. For images, it might be the details of a scene, the object style, the mood that I want to convey. Instructional prompts, these guide the model on how to perform a task, such as explain the concept of relativity or create an image of, some type of futuristic city. Finally, there's conditional prompts. These kind of include conditions or constraints that the output must satisfy. So I want you to write a poem in the style of a famous author, or generate an image without any type of humanoid figures in it, right? It's do this, but don't do this. Now, we can give it all the instructions, but we don't really have that as our only handles and controls. And I wish I could have showed you examples of a application here, but again, if there's many examples on the web if you want to search for it, and they'll typically have a GUI to similar to what you see over here, where you can actually adjust it, or it could be command line interface, where you're going through and manually coding this in. But you'll typically have something called a temperature control, and The temperature control controls the randomness of the output. So a higher temperature control results in a more novel and diverse result, potentially at the cost of coherency. A lower temperature produces more predictable and conservative results, closely following the training data patterns. So again, higher will produce kind of more creative results from your prompt. Lower will make it more of a conservative approach. Sampling steps, this parameter determines how many steps the model takes to refine the generated result. The more steps generally mean the output will be more refined and detailed, higher quality, if you would. But it also comes at the cost of computational resources and time. So there's often a point of diminishing results when it comes to sampling steps. The image itself, say we're doing an image-based model, it may only have so many pixels or the size of the image that it can pull from. So if you tell it to sample the entire image to create it, and it creates a result, it actually may only be able to hit a certain threshold before you're just taking extra computer resources without actually tangibly benefiting from a higher quality result. So there's a little bit of fine tuning that gets involved with that. Guidance scale, or CFG. This scale is, adjust the influence of the conditioning. So if it's text, it could be text prompts on the generation process. A higher guidance scale makes the output adhere more closely to the specified prompt, potentially at the cost of reducing diversity. A lower scale, though, may result in more creative, less controlled type of outputs. When we're talking seed, that's setting a specific example value that allows you to generate the same result repeatedly. So say I'm using an image-based model and I'm generating images of these children, and I go, okay, this is great. I want them to always be in this position where they have the rock and roll hands in front of the keyboard, this type of lighting, this theme, this mood. I may set my seed at a level that so it repeats this, and then I can just do small iterations based on the content I'm producing. Max tokens, you typically see this with text-based models, but you could also be with image models, not necessarily a token, but it could be max pixels or resolution. And that's the maximum length of the output that you really want to create. So why would that be important? Well, it could be crucial for specific applications. So say I want to send a tweet and I don't want more than 280 characters. I can set the max token length so that responses never exceed that 280 character word count. Finally, something that I kind of want to touch on here, it's a bit of prompting, but it's used both when it comes to more refining that not necessarily prompt engineering, especially when it comes to image-based models. Negative prompts. So these are used to explicitly tell model what to avoid when generating images. They can be useful for steering and get rid of unwanted elements and fine-tuning the aesthetics of an image itself. So say I am creating an image and I don't want to have a background. So I may tell it, in a negative prompt, no background, no landscapes. I may tell it if I want to have a image of a man and he's wearing a hat, I may tell it to eliminate the hats I don't want, right? It's telling the model, hey, I want you to create something, but I don't want you to create this. Okay, it's been a lot. And the reason why we've already talked so much about different models and training, data curation, and things of that nature is Gen AI is already everywhere. Many people use them without even realizing that they're using it. It's in chatbots, virtual assistants. It's used to generate human-like responses, and with your synthetic your smart speakers. Streaming services use it to employ content recommendations. So, hey, we may think you might like these shows based off your user preferences. I'm sure you've seen it in auto completion in your email services or on your smartphones using predictive text to figure out what the next word in my text message is supposed to be. It's in photo editing tools that utilize AI to enhance images. So say I have a low quality image, I could tell it to, hey, look at the lines of this blurry image and refine it so that it becomes more in focus. It can also remove backgrounds. You may have seen that on your smartphone devices as well. So there's a number of ways that we're already kind of experiencing this technology. And it's really based off of these foundations. And I thought this was hilarious, by the way, because obviously, as I've talked about in the past, I have a lot of stock imagery in here. I started searching for stock imagery of foundation models, and it never occurred to me that they were going to show me models applying foundation to their face. Lesson learned, but I thought it would be fun for the presentation. But foundation models are advanced machine learning models trained on vast, diverse data sets from wide ranges of sources. They are designed to capture a general understanding of the world through data, and then apply this understanding through specific tasks. These models are foundational because they serve as a base upon which numerous specialized applications can be built without the need from training a new model from scratch every single time. So examples of foundational models could be GPT, Llama, Vincuna, text and image models like DALL-E, Stable Diffusion. And the idea is there's a lot of computing resources that go into training one of these models. It could take months, could take years, could take vast amounts of wealth to create one of these foundation models. And then, especially on the open source community side, you could take one of these foundational models, retrain it, fine tune it, so that it could be more appropriate to your specific task. And as we talk about fine tuning, let me explain what that really is. And that's where a pre-trained generative model, which has already learned general patterns, features from a large data set, is further fine-tuned on a smaller, more specific data set. So think about like the DoD, where okay, I may have a large language model that's really has a decent understanding of generative AI, but it doesn't necessarily understand how the DoD is applying it. So I may have PDFs of documents, and I may have additional guidance or white papers that I want to produce that maybe is not available to the public, that I want to train a model so that I could have a predefined behavior be more accurate. That's really what fine tuning is. This additional training helps the model adjust its weights and biases to perform better on tasks that are closely related to the data that I wanted to produce. So you may be wondering what the picture of the dog is, wearing glasses, and how it really, studying charts, how it relates to fine tuning. The answer is it really doesn't. Stock imagery, this was placed here for your enjoyment. Now, we've talked a bit about these large language models, or LLMs, and they've really been the catalyst to a lot of this generative AI revolution that we're kind of seeing. They're general purpose models pre-trained to solve common language problems. LLMs are typically trained on text in a supervised manner, where the model learns to predict the next word in a sequence, given the words that have preceded it, right? So they require large, diverse data sets to learn a broad understanding of language, context, knowledge. Training LLM, though, requires a significant computational resources, often necessitating use of specialty GPUs. The quality and size of the training data significantly impacts the model's performance. Even though we are starting to see a resurgence of these smaller language models kind of popping in that are more targeted to approaches, but still large language models are really kind of the king at the moment. And so they can be fine-tuned. LLMs do not need to exist, though, in the cloud. So that's how most people may be aware of cloud instances like GPT. But you can actually host them locally as well, which is really good for the DoD because, again, we have data, we have controlled unclassified data, we have classified data. There's certain things that we don't want to exist in a cloud instance. We don't know necessarily where those servers might appear, where they may be located. So having a little bit more control and being able to deploy this locally is kind of one of those nice things, as long as you have the computing resources to do it. Now, image generation models are a subset of generative AI intelligence models. We've kind of talked about with the Stable Diffusion and DALL-E examples prior in this presentation, and they focus on creating visual content from a given input. which can be either like a textual description. It could be another image. So I could say, hey, take an image of a library and make another image of a library. It could be a combination of these two, where I tell it to make an image of a library, but make it a fantastical scene, where I mix futuristic content in and sci-fi and fantasy elements, kind of like the example that you're seeing here. These models leverage deep learning techniques, particularly neural networks, to understand and interpret the input data and subsequently generate new images that are coherent and contextually relevant to the input. So, the most type of image generation models include those GANs that we talked about prior, but they can also use something called variational audio encoders. These autoencoders are models that are based on the principle of encoding an input into a latent hidden space, representing and decoding this representation back to the original input. So that's, again, I have an image, try to recreate this image, essentially. They learn by compressing data into lower dimensional spaces, then expanding it back, allowing them to generate. So, they may start training on an eyeball, refining that eyeball, mouth, nose, face, eventually becomes a head. Diffusion models, these models start with pattern of random noise. They generally refine it to a coherent image through a process that reverses the fusion process. They iteratively denoise the image, guided by the conditional model that incorporates understanding of the input description. Okay. Now, none of these are perfect. Gen AI hallucinates. It'll return a response with the confidence of 1,000 Dominic Rosses, despite having no factual information. This phenomenon occurs across various forms of generative AI, including text, image, audio models. Understanding why these models hallucinate is crucial for improving the reliability and trustworthiness of AI systems. If a model's training data is not comprehensive, contains bias, or has poor guardrails in place, and a guardrail is something that's put in for protection. Say I have a large language model and I don't want a bunch of racist type of responses or vulgar languages. You may put a guardrail in place saying it not to do this. But that in itself, that guardrail can also cause a negative hallucination, because I could say, okay, don't generate images of a demographic that appear to be poor. And then when I try to force the model to do it, it may incorrectly avoid that topic despite, a user prompting for that type of action. So how do these models hallucinate? Well, a text model will hallucinate. It may fabricate facts. It may provide inconsistent statements or nonsensical replies. And this really occurs because the model is predicting what word will come next based on the probability and patterns, rather than a true semantic understanding of what the subject matter is. It's really just guessing its best probability of what the next word should be. Image models, they may generate images with unrealistic or impossible elements. So, I may create a picture of a human and it has a hand, but that hand has 7 fingers, because the model knows that a hand's supposed to have fingers. It just may not know that my human model is supposed to have 5 fingers. Or it may, create a human, but then have a conjoined head that's coming off the side of it, almost like a Siamese twin effect. Or it may have a photo of a woman and have an earring on the right, but not an earring on the left. Have a button on the right that is a different color than the left, or 2 different color eyes. Those are ways that images can kind of hallucinate, but they also help us detect synthetic material. Audio generation models, like in speech or music, they can hallucinate by creating garbled speech, unnatural tones, music that just doesn't adhere to any type of harmonic rules. So how do we mitigate this? Well, good news is most people's jobs are safe. When we talk about human in the loop or on the loop systems, that's what we're really talking about: incorporating human feedback into the AI training loop, so we can identify and correct these hallucinations and refine the model's outputs. as a user, you need to fact check the results of everything at this time. So think of yourself like an investigator who needs to corroborate information. Maybe get two verified sources to be safe before you put, something that's produced by a large language model into your report. Model creators need to also ensure, though, that the data is both large and diverse, which can help models develop a more balanced and comprehensive understanding, reducing the impact of single outliers or bias. So it's really garbage in, garbage out. If I have a data set that, only is trained on data of one demographic showing this one type of response, and then I prompt it to create this response, well, I can't be surprised the fact that it hallucinated and didn't generate the response I was looking for, right? So if it's not diverse enough in the data set, doesn't contain enough examples, then it's obviously going to cause hallucinations. Okay, so we have a good understanding now of different types of models, how they're trained, how they're curated. Let's talk about the importance of Gen AI in modern warfare. It's really speed. AI is accelerating how quickly we need to respond to incidents and plan missions. Whoever's faster with a good strategy typically has the advantage. AI allows individuals to do their jobs faster, safer, and better, changing how we envision and how we design, how we iterate and how we validate, and more importantly, how we scale. So where does Gen AI really fit within the military? Accelerated response and planning. Generative AI can create simulations of enemy actions based on limited input data, allowing for faster development of counter strategies. It can enhance performance and safety. So generative AI can design realistic training scenarios that adapt to trainees' performances, enhancing readiness while ensuring safety. Generative AI can propose various military strategies by synthesizing vast historical conflict data, providing a strategic advantage of innovative new tactics. You can use generative AI. The military can rapidly evolve drone designs by generating and evaluating multiple structures and functional configurations synthetically before it ever actually becomes a practical deployed, hardware device. Generative AI can enable drones to adapt their behavior based off of evolving dynamics of their environment for the mission. For example, drones can modify their flight pattern and tactics in real time, optimizing the path for surveillance or combat based off the data that they acquired during the mission. In scenarios involving multiple drones, generative AI can facilitate, if you think like bees, like a swarm type of behavior where the drones communicate with one another and have a hive mindset to make a decision. Generative AI models can generate virtual environments to test and validate scalability of logistics strategies across different terrains and conditions. So I can take a data set from a drone, I can record that, I can create a 3D virtual environment from that data set, and then I can decide, okay, what's the path of least resistance? Where are my choke points? What type of SCADA systems are involved? What do I have to worry about? Where can an adversary hide? There's a number of ways that I can actually validate what my plans are going to be and create a strategic advantage just using synthetic material generated by AI, as well as going through and testing and validating my assumptions for mission planning. It's imperative to develop safe, reliable methods for utilizing Gen AI. In the near future, the military commanders will be able to swiftly evaluate battlefield scenarios by integrating all this historical and current data with predictive analysis. This rapid processing will enable the analysis of enemy movements, translation, and the annotation of communications, and the prioritization of military targets within seconds. Such capabilities are crucial to be conceded to adversaries. And how do our adversaries think about this? Well, this is a quote from 2017 from Putin. Artificial intelligence is the future, not only for Russia, but for all mankind. It comes with colossal opportunities, but also threats that are difficult to predict. Whoever becomes a leader in the sphere will become the ruler of the world. So shows how our adversaries think about Gen AI and what importance they're putting on mastery of this domain. I think it's a good reason why there's a limitation on GPUs being shared throughout the world outside of traditional chains here in the United States. So how can our adversaries use it against us, right? Big way is misinformation. So Gen AI can produce realistic fake images, videos, audio recordings that can be used to spread misinformation and disinformation. This could be involved in fabricating speech from a political or military leader to mislead the public or enemy forces. On the defensive side, generative AI can be employed to detect deepfakes and other type of AI-generated false content by analyzing patterns that may not be predictable by human eyes. So a lot of us may be familiar. There was a deepfake video of Ukrainian President Zelensky appearing to announce that Ukraine was surrendering. This video was part of an effort to undermine the trust and create confusion among the Ukrainian populace and international observers. On the flip side, though, there was also a deepfake curating showing Russian President Putin purportedly announcing peace with Ukraine, which was also intended to spread disinformation. So it's already being used in modern warfare. And especially with the election coming up soon, I think we can all expect to see a rise in deepfakes and misinformation campaigns. And the real problem with misinformation is not necessarily identifying it. It's just once it's in the wild, it's already too late, right? How many people have seen newspaper retractions on a story? How many people actually read those retractions versus their initial story? It's kind of the same thing when you have a deep fake. You may see it and believe that it's easily detectable and understandable that this isn't real, but there's a large part of the population that may miss that, or maybe they're watching on a device without the best fidelity and never see the retraction. So it's something we're going to see more and more. In fact, you even see it now targeting elderly population. I think there's a technique called pig butchering that's fairly popular, where they're using misinformation, large language models, generative AI, deep fakes, and in attempts to take money from seniors. Well, what's our DoD doing about it? Well, they recognized its importance, and so Task Force Lima was launched back August 10th, 2023. And they're responsible for analyzing and integrating generative AI technologies like large language models across various DoD operations. This includes areas such as intelligence gathering, operation planning, and administrative processes. They are in the process of introducing a virtual sandbox platform, which allows military personnel to explore Gen AI tools in a safe environment. They're going to assist with assessment and synchronization. The task force is going to evaluate AI capabilities within the DoD, ensuring that the deployment of these technologies is synchronized across different departments to avoid redundancy, and hopefully maximize those efforts in this field. It can help with risk management. It's focusing on identifying mitigating risks associated with generative AI, such as the issues stemming from poorly managed training data, vulnerabilities that could be lead and exploited by our adversaries. Also setting up strategic partnerships with like even FFRDCs like the SCI where I'm a part of. So they're going to work to collaborate with other departments within the DoD, as well as intelligence community and government agencies to leverage expertise as a resource effectively. And I know they've also recently, I think, launched a responsible AI toolkit, and where they talk about the ethics and use of AI. And so the U.S. Department of Defense has outlined 5 key ethical principles to guide the development and deployment of AI in the military applications. First, responsible people in the DoD will make sure that they're careful, exercise good judgment and accountability for how they develop and use and deploy AI. It needs to be equitable, right? The DoD will try to make sure the AI doesn't unfairly favor certain groups or ideas, whether it's political or demographic. Traceable, DoD will make sure individuals understand how AI works, how it's developed, and how it should be leveraged, recording data sources and documenting methodologies and procedures. Need to be reliable. The DoD will use AI with well-defined use cases. They'll test to make sure it works safely, securely, and effectively from start to finish. Governable, the DoD will design AI to do what it's supposed to do. Monitor it for unintended consequences and make sure it can be stopped and repaired if it starts doing something it's not intended to. A good example of this is recently the DoD Directive 3000.09, and that provides a comprehensive guidelines for integration and supervision of autonomous and semi-autonomous weapon systems with a strong emphasis on safety, human oversight, and ethical considerations in military application. So, some key points on how it's like looking at generative AI in the 3000.09. Human controls and ethics ensure that all autonomous weapon systems incorporating human judgment capabilities align with ethical principles to minimize unintended harm and maintain accountability. Test and validation, emphasizing rigorous verification, validation, and testing protocols to ensure that AI systems behave as expected under diverse and challenging conditions, thereby reducing the risk of failures. Again, we talked about transparency and understandability. The directive requires that the human-machine interfaces be transparent, making the systems function understandable to operators, which is crucial to trust effective management of AI systems. AI ethical principle compliance, it mandates adherence to DoD AI ethical principles, can ensure responsible, equitable, and governable use of AI technologies within its systems, specifically weapon systems. And finally, having a robust review process, establishing a structured review process involving high-level approvals for new systems or significant modifications of existing systems. So reflecting a careful and controlled approach to deployment of AI capabilities in the defense setting. With that, in conclusion, the generative AI course that I kind of went over with you provided hopefully a comprehensive exploration of generative artificial intelligence, delineating its connections between machine learning, deep learning, and the broader AI landscape. We've delved into various forms of learning, supervised, unsupervised, semi-supervised. We've examined complex models such as neural networks, GANs, and both discriminative and generative models. We've highlighted the nuanced differences between predictive ML models and generative AI models, and we've talked about understanding the transformative impact of technologies such as transformers. We explored the practical applications of generative AI, such as datasets acquisition, curation, and advanced techniques in prompt engineering. We've talked about some real-world type of scenarios of Gen AI, often noticed, or I should say unnoticed by users, as well as where it fits within the DoD when it comes to modern warfare and the generation of misinformation through deepfakes, emphasizing the importance of ethical considerations and mitigation strategies. So as generative AI continues to evolve, one thing I really want to stress on this, especially because it's evolving so quickly. There was a tech keynote just yesterday about how a major tech provider is advancing their own capabilities. We have to evolve with it. Realize that's a lot in a little bit of time. I'm going to turn it back over to see if there's any questions. I feel like I've been talking for a while, so I'm going to take a quick sip of some tea.
Hey, thanks, Dominic, for that great presentation. We have a couple of minutes for questions and way too many questions for that couple of minutes. Let me just go through some of them. One thing that came up was about tech data rights and ownership of things produced by generative AI. For example, you showed the chef, which looked like it was AI generated. Who owns the copyright of that image? Is it the prompter? Is it the software? Has that been worked out yet?
That is actively being litigated as we speak. I'm not a lawyer, so I don't want to give the impression that my word is law. What I can say is there, in the artistic community, if you're developing art, there is a expectation of reasonable change that has to occur when you're generating a new work or image. So there's a famous example of this where during President Obama's campaign, there was a poster that said hope on it. And an artist took a image from the Associated Press, I believe, and painted over top of that image and wrote hope at the bottom, and was subsequently sued. And the lawsuit was eventually dropped because it gets kind of tricky into how to point who owns the rights of a image once it's been manipulated past a certain point. When you think about data that AI is trained on, a lot of these organizations that are creating these foundational models will say that they train on publicly available data that has been scraped, that is open for anyone to access without advanced parameters. And thus they believe that they are in their rights to use them for training generative AI models. It'll be up to legal battles of the future to determine whether or not that is a wise decision, I guess, by these companies. I think there'll be some type of happy medium eventually. I can tell you there are some companies building models that are using and paying artists for supplying their data.
There's a question about the speed of the systems. I think one piece of it is, what's the speed of learning? And should that cause concern, especially in a operational real world circumstance? And the other is the speed of delivery. For example, how quickly can a system like this build good software?
Right. Speed of learning can be slow. So these foundational models, especially the larger parameter models, can take years to train. Fine tuning can be relatively quick though. So when we talk about speed, further refining a foundational model can actually be done in a matter of days, weeks, to months, depending on the complexity of the fine tuning that you're looking to do. The second part of your question was,
how quickly can it deliver good usable software?
That's currently being evaluated now. I know Task Force Lima is currently creating a framework based off of how quickly you can actually evaluate and develop that. I would say that is unknown at the moment. There are APIs that are used. It gets into trustworthiness of AI and responsible use of it. I would say come back to us in a year and we'll have a better answer to that question.
And then we've got time. I'll let you do a little bit of a commercial. There's questions about how people can dive deeper, learn more. Can you talk about other offerings maybe coming out of SEI or Carnegie Mellon that might be of interest to the audience?
Yeah, I can tell you internally, we are getting ready to release a number of public offerings. So I can tell you the one is an introductory course in the AI that we're going to be making available to a larger landscape. Email info@sei.cmu.edu for more information on that. We also have some additional courses like uncertainty quantification, responsible AI that we're working on. But honestly, the video tube sites are also a great resource. There's a really strong community that is going through, especially if you target the open source community, on how to best leverage these technologies. And it's not just data scientists, they're creators, there's high school students. Like I tell this to a lot of people, the best talk that I've ever seen on prompt engineering was given from a 16-year-old intern. And so what I would say is, web searching can provide great resources. There's obviously platforms like LinkedIn Learning and Udemy and other things. I can't recommend anything outside of that, but I can tell you the SEI as a whole will be producing large vast of content that we're going to be making available to the public soon.
That's great. With that, I want to thank Dominic for the great presentation. I want to thank everyone for your attendance and all the great questions. We're going to post the recording online as soon as possible. If you have feedback about this event, especially topics you'd like to see us cover in the future, please email us at eti@ndia.org. I want to take this opportunity to highlight a few of ETI's upcoming events. The second NDIA Emerging Technologies Conference is going to be held August 7th through 9th, 2024 at the Washington, D.C. Convention Center. Confirmed speakers include Deputy Secretary of Defense Kathleen Hicks, Vice Chief of Staff of the Joint Chiefs of Staff, Admiral Grady, DIU Director Doug Beck, and Undersecretaries Shu and LaPlante. The Service Acquisitions executives would be there, as well as other government and industry leaders. Last year's event was sold out, registrations, exhibits, and sponsorships. So you have to move fast if you want to get in on this year's version. Information on all of these opportunities, plus opportunities to present some of your own technical work at the event, can be found at ndiatechexpo.org. Our next Tech 101 is on trustworthy AI. That's going to be June 26th, 1 o'clock. Registration should be open soon on the NDIA website. And then I wanted to talk about the Emerging Tech Horizons podcast, ETI's own podcast. Some recent episodes have been on things like the PPP Budget Commission's reports. We're dropping one this week covering a summary of what happened in the FY24 appropriations bill. Upcoming ones will be on NAVSys technologies, which are an alternative position, navigation, and timing, NDIA's vital signs report on the health of the defense industrial base, and other topics. The podcast goes out on YouTube, Spotify, Apple Podcasts, all the platforms, and we're always interested in ideas for topics and guests. With that, I want to thank everyone and Dominic for this great presentation. Thanks for joining us today.